Hello, this is my 4-bit computer that I built over a year ago, maybe even 2 years ago, and it's loosely based off of the design that Van Eater proposed for the 8-bit computer. I've trimmed it down a bit. I cut out some of the components, such as I haven't built the ring counter for it, and I have also the instruction set is kind of basic, but I'm gonna go ahead and explain each module of the computer and how everything works. So first there's the clock. It's controlled with the 555 timer, and that's basically for the registers and just the overall timing of the computer. This is the A register output, B register output, a magnitude comparator that shows which register has a bigger value. If it's red, it shows the A register has the bigger value, which you can see is true. I've pre-programmed a few values into memory. This is the address and the memory data controller. So this is for the address. And address 0 I've programmed in a 1, and in address 1 I programmed in that 2. And then this is the read and write push button right here for memory. So I've programmed in that data so far, and I'm just gonna I already did the accumulation, so I added the two numbers, but this ALU is capable of doing addition and subtraction. I'll show you that in a second. This is the bus. The ALU is capable of outputting to the bus but not taking an input, because it wouldn't make sense for it to take input from the bus. A and B registers could output and input to the bus. And I forgot to mention the accumulator is over here, so you could control whether it accumulates the data in A and B. And then, okay, the memory is over here, same thing with the memory. And then the memory address register is here, memory data register is here. This displays the value that's on the bus. So this wire controls these four right here, control what is outputting to the bus. So if I output from memory to the bus, you'll see a 1 on the 7-segment display. And if I output from the ALU currently has a 3. So you'll see there's a 3. It's a little bit messed up. Yeah, there you go. There's a 3. So this other one lets you output from the registers, these two. So if I pull this one up, it'll show what's in the A register, which is a 2. Again, that top thing is kind of messed up, but that's a 2. Yeah, this wire is just loose. It's supposed to be a 2. And then if you bring this one up high, it'll show a 1, because that's what's in the B register. There you go. There's a 1. And then this one allows you to take data into register B. This blue one is for register A. This one is accumulate. This one controls whether you're subtracting or adding. So now we've already done addition, so I'll just show you nothing's gonna happen if I do this, because that's the sum of 1 and 2 is 3. But if I switch into subtraction mode right now, and then I deaccumulate, you'll see that it'll only output a 1. And then this red light turns on to indicate it's like 2's complement or something like that. I forgot why that turns on, but it's basically just the carry bit. The carry bit turns on when you're subtracting, and it shows a 1. Now if this was a negative value, so let me see if I could really quickly do a register switch, value switch. So I'll output it from the, so this one is to output from the A register. So I'll output it from the A register, and I'll take it into the B register, that 2. Cool. So you could see the yellow light turned on. They both have the same value. So now I'll program this one that's already in memory location 0, and I'll put that value into into register A. See, that's a 1. So memory register B has the bigger value. So now what I'm gonna do is I'm gonna do that subtraction. So you could see this turned off, and there are these 4 lights on. So that shows a 15. But since this is off, you would do 2's complement, which is basically you flip all the bits and add 1. So if you flip all of these, you would get 0, 0, 0, 0 plus 1 is 1, which is correct. 1 minus 2 is negative 1. This being off shows is basically a negative. That means negative. And when it's on, it's positive. So that shows basically all of the operations of the 4-bit computer. I may add more, like I may have to add I forgot what, the program counter or the ring counter. I might want to kind of clean up this controller here. I want to also add something that I could clock pulse 1 time so I could kind of see what's going on better through each step of a program. But that's pretty much it. There's another thing that I actually built. Instead of having this 7-segment display driver, this 7447, well, this one can only output numbers from 1 to 9. When you reach 2-digit numbers, it can't do hexadecimal like A for 10, B for 11, etc. This that I built actually, and I programmed it with this. You would hook up the Arduino pins to here, and it's just shift registers that let you program this EEPROM. And I programmed in this data that if I plug this in, I could do 1 through 15, I think, and it would do it in hex, 0 to 15 in hex. So it would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then the 10 would be A, B, B for 11, C for 12, etc. So that's something that I could replace as well. But so far, I'm quite happy with it. Everything works great. And also to power it, I'm just using a 1 amp iPhone charger and this little power I made here, and I have a filter capacitor. I usually like to put those in my projects because it ensures that you will get a clean power through your circuits, so you don't have to worry about that. But yeah, that pretty much sums everything up. Thank you for watching, and I'll keep you guys updated on any updates I make to this project.